Good afternoon, everyone. My name is Marius Buchmann. I am the host of this afternoon session on innovation in trading. And we are looking forward to very interesting presentations circling around different digital solutions that can be applied to trading. My background, as you can see here, is I'm a researcher. I'm heading a research group at a small university in Germany, and have my own small private consulting company. And that's it to my person. If you're keen on learning more about me, we can discuss that later on in the coffee break. I will try to set a little bit the scene for the presentations we will see this afternoon. We will have a diverse set of topics that we will discuss, from technological solutions to increase data availability and quality, via blockchain applications for energy trading, the regulatory challenges of blockchain technology, and then we will have insights from those utilities that are currently involved with one larger blockchain approach on trading, the Enerchain project. What I want to stress, and I dove a little bit researcher, I searched for some data that's interesting to motivate a little bit this afternoon. And what I found is this statistic from, I must admit, rather old, from 2013, a report by McKinsey. And what they did is they compared the cost per trade between financial traders and energy traders. And as you can see in this slide, the cost per trade it's a little bit small, so I briefly introduce it. The darker blue are the cost per trade for energy trading, and the lighter blue for financial trading. And on the horizontal scale, you can see the volume of trades in thousands and the cost per trade. And what you can see, obviously, there is a huge difference. And for companies that only execute only 10,000 trades per year, this difference between financial traders and energy traders adds up to roughly 65 euros per trade, which equals 4 times, roughly 3 times, roughly the amount a financial transaction takes. So there seems to be an, let's say it optimistically, window of opportunity to cut costs. Obviously, the products are not completely comparable, I'm aware of that. But here we are comparing cost per trade, which means that we are talking about all the back office processes and everything that has to happen to execute a trade. And that is not that different if you take a closer look at both systems. Interestingly, it's not about scale economies or something. What you can see here is it's rather stable. There seems to be a difference of roughly 25 euros per trade between financial trading and energy trading. And this raises the question, well, why? I don't know. What the consultants from McKinsey claimed was that there are 15 fields where you can improve. And as you can see, 15 fields means that on average, they are all bits and pieces, and there's not one large cost part in the trading process that could be optimized. But in general, the assumption is that applying digital technologies to the back offices, to the repeated processes, to gather data, to process data, can significantly cut costs related to energy trading. This is a very general statement, I'm aware, but I like this data set as it motivates where we could go and what the window actually might be. This then brings us to the second thought, or at least me brings to the second thought. Well, okay, so probably utilities are investing like crazy to bring down these costs. I don't know about that either. What I found is the data from the International Energy Agency, published, I think, in the beginning of last year, where they collected data, and there's a bias in this data, I'm aware. They collected data how utilities that have a network operating business as well invested in the context of digital solutions. And what they found was, and that's a very promising view, that in the time period, which is very short, from 2014 to 2016, the investment into digital infrastructure and assets, etc., increased by 20% annually, which is a good story. If you take a closer look, what you see is it's nearly all is asset-based, which is not surprising, which is actually fine because utilities are asset-based companies, at least in generation, and networks, trading not so much. What's interesting, and I don't know whether I can interpret these numbers that far, but what you can see here is the light blue. That is the investment into software by these utilities. And this does not differentiate between software for trading and software for network operation. It's just a large number. And I'm not interested in the number, I'm interested in the relation. First of all, this light blue part didn't increase, which is a message in itself. Because we are all talking about digitalization, and at least for those utilities, that means investing into assets. It's not investing into software, which is an interesting finding if you think about it. And what you obviously see is, not surprisingly, as we're talking about an asset-based industry, compared to the investments into assets, software investment is rather unimportant. Which brings me to the key question for this afternoon, which is, well, is it really the case that even though there seems to be a huge cost optimization potential in energy trading, that utilities are not active that much, or are they active and these numbers just don't reflect it? And what are the incentives for the companies to apply digital technologies? And what we want to discuss this afternoon, and thereby I'm already at the end of my introduction, is what are potential digital solutions, approaches to improve the efficiency of energy trading. We will start with a presentation soon that will focus on the question how to combine different data sets and with the purpose to improve the potential revenues of energy traders. We'll have another presentation this afternoon, how to gather most efficiently different data sets outside and inside the company to have high quality databases for example, algorithms. And then in the storyline, it fits quite well. We will discuss potential of algorithms, algo trading, and other options like robot automated processes, etc. For energy trading. And then we will move away a little bit from the established business, where we could save money with these technologies, to the more future perspective. Well, obviously we are at the European Utility Week, and there won't be many panels where we don't discuss blockchain, and this happens here as well. What's special about the sessions you will hear today here at this hub is first, we will take 3 different perspectives. The first, and I'm pretty sure that is the only presentation on this issue here at the European Utility Week, on the regulatory perspective on blockchain in the energy sector, where we will hear from the regulator here in Australia, that would be interesting as well, Austria, how they see, or which perspective they have on blockchain technology in energy trading. Then, as a second perspective, I hope that he will show up. We will get more the investor perspective from a utility that is investing into blockchain technology. And the third perspective then is the specific project Enerchain, which last year conducted its first gas and electricity trading here on this hub stage at the European Utility Week in Amsterdam. And they will present to us their insights from the consortium, where we will have different parties from the Enerchain project, utilities, as well as the people from Ponton to show us what they did in their project. This is our afternoon, and this was my introduction, and I would say that we now move towards the presentations, brief information for you. We will have different length of presentations. The first presentation will be something around 20 minutes, 25 minutes. And you will always have the chance to ask questions. We have this nice microphone that I can throw at your head, and then you can ask your questions. There's not much time for questions. We will have 1 or 2 for each presentation, but there will be a coffee break in between where you can take a closer discussion with the presenters. Okay, then having that said, I would say we move on to the first presentation, perfectly on time, by Andre Yeager. Andre Yeager is from OpenLink, where he works now for more than a decade. And since 2013, he's head of the Energy and Commodities department and the product management team. And since 2015, he's heading the Berlin office as well. And he will discuss with us about how real-time analytics enable algo and programmatic trading success. And he not only will introduce to us where his company sees the most benefits of these approaches, but which experience he made with his different clients. And I would ask you to come up and present. Give a nice welcome, please, to Andre Yeager.
Vielen Dank. Thanks a lot. Can you guys hear me okay? Perfect. See some nodding heads. So, quick introduction. As Maurice already said, I'm already more than a decade working for OpenLink. I think I had the luck to kind of move through various roles and locations. I worked 5 years out of New York, where it's kind of our main development center. I started originally on the Berlin side, so you hear a slight German accent, and eventually moved back to the Berlin office, as he said. And yeah, responsible for product management. And so the title of today's presentation is The Need for Speed, How Real-Time Analytics Enable Algo and Programmatic Trading Success. Do I have to anything to maximize it? All right, that looks better. I think it's a successful video game series on the racing car side, Need for Speed. Or I never played it, but at least based on that, I liked our title of the presentation. Let's try it. All right. Earlier it should be possible with a swipe. So I will start with a brief introduction to OpenLink as well as Ion. You might be aware, OpenLink was bought recently by the Ion Group. And I will start out with talking a little bit about kind of some of the market observation, especially also what we see on the existing client base on the OpenLink side. And then talk a little bit more specifically about a project we're currently conducting together with RWE to kind of expand and invest in this particular area. And then I will finish off with summarizing some of the value benefits that we plan to get out of that joint investment itself. So as I said, quick introduction to Ion. I think it's an eye catcher, that chart. So just briefly, a fintech company, around 4,000 employees, 40 offices worldwide. Large set of solutions, big focus around digitalization as well as automation. With 3 main kind of customer segments we're serving to. One is the financial institution, one is kind of government and central banks, and the last part is what we call corporation. And as part of the kind of solution portfolios, we have actually 4 ETM solutions with Endor, right angle, triple point, and aspect. And as I said, my background is mainly on the OpenLink side itself. So if we look at the market, and as I said, it's mainly based on the client interactions that we have on a regular basis, obviously. So we see across the board an increase in liquidity, and that usually goes hand in hand with a lower trading margin. And that, on the other hand, kind of results in the fact that everybody's looking for additional revenue opportunities itself. And two of the main focus areas, I think there's a couple of other focus areas for our clients as well, but two ones that I want to kind of include in today's discussion is one, is the business agility, the ability to kind of quickly react and take advantage of new opportunities. So everybody's looking into increasing the agility of their company. And the other bit that's very prominent is what we call high volume trading. Don't want to call it high frequency trading. I think in relation to energy, it's more like a higher frequency of trading. So we see increased trading volumes, maybe overall the same amount of megawatt hours traded as traded previously, but just distributed on a larger amount of transactions. So now I want to go a little bit deeper into what we see on our client base, and especially around the kind of how high volume trading topic. And we have the advantage that we have a kind of very active user group in this particular case that's very vocal about kind of what they want, what's happening. And it's great for OpenLink, so we get a lot of insights on kind of what's happening in the market, but I think it's also good from a client perspective to get that interaction with kind of peers in the market. In this particular case, the European user group, which is kind of the main driver of the algo trading or the high volume trading activity, consists of 17 clients. That's not all the clients that we have on the European side, but it's kind of the subset of more active ones. Mainly utilities, a couple of oil majors, traders. And what I brought back is a couple of numbers, what they're already doing today from a trading perspective. And between those clients that we kind of engaged and kind of did a very specific questionnaire around that, they're currently today already at 10,000 to 30,000 trades per day. Most of them are power related, close to 99% are related to exchange traded transactions, very little OTC. And here, peak volume number, since kind of usually distribution across the day is not equal, was around 4,300 trades per hour. This is if you compare like how energy trading looked before, is quite a different way how the ETM needs to handle that type of volumes. And the other thing what's important, none of them kind of really expect that data volume to decrease. Everybody is really expecting that that will increase further on the markets they're already trading, but potentially also in additional markets as well as additional commodities itself. The other thing I wanted to dive a little bit into is that business agility topic. So there's a big focus on kind of enabling that on the company side, and there's various investments, especially around the technology side. So the first one is also the one I want to dive a little bit deeper in, is around real-time analytics. So it's all about kind of increasing the data, the timeliness of data. You need to make quick decisions. It's about reliability, because you're basically flying blind if you don't have the data available. And it's about scalability, because the volumes are already high and they will increase further. The other big topic for our clients is, of course, cloud as one of the ways to enable it. Just kind of efficiently handling big data, being able to ramp up and down, and use some of that native scalability that comes with the cloud as a more cost-effective way. And then, of course, those volumes are not created by manual trading activity. They're mainly driven by programmatic trading. So everybody is doing various projects in the direction of algo trading, programmatic trading itself. And then I would say the last one is a little bit in the early stages to look into how can decision-making be further optimized by utilizing AI type, machine learning type of technology to kind of further improve the bottom line at the end. The other thing I want to quickly talk about is kind of the collaboration that we have around algo trading. We work actually together with Paul in this particular case. Because especially if we look at the power market, it's very important that algo trading is very closely related to a scheduling solution, because from a timing perspective, what you trade there in the intraday side needs to be scheduled almost right away. And having that partnership in place, it always, or also gives us kind of a nice perspective on a different set of clients. And what Paul actually hearing in the direction for specifically for the algo trading activity and engagements is the key for enabling algo trading is that real-time integration. With one side is the ETM, and that's also one of the reasons we're cooperating to make that simpler and easier for the clients and more streamlined. But there's so much other stuff you need to kind of integrate in real time to be able to enable your algo trading tools to kind of make quick decisions, market orders, scheduling system as I mentioned, the exchange to execute the trades, optimization models, you need to know your marginal costs. So a lot of other data that needs to be fed into the algo trading solution in a very efficient and with a very efficient timing. The other thing I mentioned already as well, kind of big focus on enabling more programmatic trading capabilities. In addition to kind of a lot of traditionally there was more manual trading, but everybody is doing something on the programmatic side. And the other thing what they see is that usually initially the clients start with a kind of utilizing some of the predefined strategies from an algo trading perspective, but very fast they're also looking into ways to get from these kind of black box approach to white box approach to kind of really be enabled to build their own strategies and then eventually kind of utilize further machine learning AI type of technology to further kind of find a competitive edge to improve their bottom line at the end. I talked the whole time about real-time analytics and want to quickly kind of summarize what we understand under real-time analytics from a kind of extraction perspective out of the ETRM system. On one side is of course the key data for algo and scheduling input. So it's all about kind of position management type of information. You want to have your physical positions on the lowest possible granularity. You want to have it around different summary groups, book, product, trader. But it's also about kind of all these other reporting figures from exposure reporting, which is a little bit more kind of your financial exposures. What's my open position? Is the risk data? What's my PFE? What's my counterparty exposure? What is my value at risk? What's my earnings at risk? And then of course, performance monitoring, how am my trader doing? How am I doing as a trader? As well as various limits and controls. So it's all about kind of making that data as quickly as possible available, and then of course with a high quality as well, because timeliness is not the most important. It's usually when I engage with people in the front office area that maybe also utilize other solution. One thing is the timing and the other thing is the quality. If the quality is not good, the timing doesn't matter at the end. Last but not least, as I said, I want to kind of dive a little bit more specifically in the project that we're currently doing, as I mentioned, together with RWE. It's a joint co-development activity, and it's all about kind of streaming kind of the key data for decision making out of the ETRM solution itself. So just from a high-level picture perspective, you have the ETRM on the one side, and you have a lot of other data sources on the other side. So you want to have that position data, but you need to combine it with information from the asset side. I talked about marginal cost. It's about kind of weather information. It's about TSO-related information. Maybe eventually the smart data be connected to that. So there's a lot of data that needs to be combined, and you need to make that data available for various downstream data consumers, including your algo trading solution itself. And there's a couple of investment focuses for us. As we're doing real-time data stream already for a while, but there's consistently kind of looking into how can we make the quality of the data better, and it's usually related to some upstream activity. Make it easier to kind of capture trades, integrate through APIs with the different trading venues. So just to kind of ensure whatever is captured from a trade execution perspective is reflected correctly. And then, as I said, it's all about kind of system availability. You need to get away from kind of that 90% available to up to that 99%, because it's just way too much operational risk to not be able to know kind of how your positions look at any point in time. So there's a lot of kind of investments where we're looking to get to that 99%. And then, of course, that data that you have in the ETRM needs to be distributed to various downstream systems. And we're kind of working in that end to utilize Kafka from a technology perspective to kind of make it easier to integrate with various downstream systems itself. And then, of course, as I mentioned before, we're working on the integration on the algo trading tool itself to kind of streamline that, make it easier to kind of get data out of the ETM, and then of course getting the trades that are executed back in the ETM itself. And the other thing, not directly or indirectly related to algo trading and related to the volume numbers I showed earlier, there's of course a big focus to kind of adjust the solution or the technology to kind of cope with the change in trading patterns. So there's a huge difference if I do a couple of thousand OTC trades versus 40,000 trades a day with that 15-minute or that hour that I kind of have certain volume executed through Apex or Nordpool. So last but not least, I just want to kind of summarize what is the reason for the investment on our side, but also jointly with our clients. So what do we want to get out, and why are we and why are our clients spending money on building that out? First of all, data quality investment, I think is probably obvious. It's kind of increase the reliability of the data. Then, as I've mentioned, high system availability, kind of reduce the operational risk to be kind of down, don't know what your position are. It's key input for the various downstream decision making, from asset operation to trading to algo trading algorithms. And then even if you're in a situation where you're down, you need to kind of have ways to recover as quickly as possible. Then of course, you want to utilize that ETM data, and you want to combine it with various other data sources. So it's all about kind of having easy data distribution and integration for enabling decision making. So it's all about the timing. So you need to have it quickly, and you don't want to spend a lot of money on kind of integrating and managing kind of a complex zoo of interfacing. I talked about the integration into algo trading. So ETM delivering some of the key input factors, and then of course you need to manage all the downstream activity. So very important to simplify and standardize that integration. That's why we kind of went the partnership route. Speed and timeliness of data. As I said, quick decision making is important. First mover advantage. And last but not least, what I showed on the volume data we received from the existing client base, that data will further increase. So it's all about scalability and being future proven, because I think we're at the start. I talked earlier to Apex. They started now with the German market. They go into further markets. So there will be a further increase from a volume perspective. So that being said, as Marius said, we will be around, and I would be definitely interested to kind of hear your part of the journey. What are you doing from a solution perspective, from a data perspective, and how do you see that going? So if you don't catch me here or you don't want to ask the question now, happy to answer everything tonight at the traders party or maybe after that meeting here in the coffee break. Thanks a lot.
Thanks for the nice presentation and the overview. Are there any questions from the audience? We have time for one or two questions. If not, then I will raise one. I've got two questions. One is rather hands-on. So what is the fastest and the slowest time you implemented your system at one of your consumers? So just, does it take, best and worst case?
It depends a little bit what kind of fast we're talking about. Also I think the quickest connection you probably want to have is more on the algo trading side to your scheduling solution or to the trading venue. I think in our situations, we have usually two types of clients. One that kind of have their real-time reporting capabilities directly on the algo trading tool, and others that kind of utilize what we have natively in the ETM side. And even in those high volume numbers where we talk like 4,300 transactions per hour, I think the expectation is that it doesn't take up to kind of 30 seconds to 60 seconds to have your positions updated on the ETM side. Okay. So you need to, and Usually that's fine if you have a single transactions, but the important thing is to kind of handle that volume. If you have like 4,300 per hour coming in, and you constantly kind of need to recalculate what does it mean, physical position, financial positions, P&L numbers.
Okay. Thanks. Now, is there another question from the audience? Okay, then maybe to connect the topics we are discussing today, and I haven't wrapped my head around it, so this really is a little bit motivated by your presentation. We will hear 3 presentations that all somehow relate to blockchain technology, and in my understanding, it just provides a decentralized way to have trusted data. Is that a technology you foresee to be complementary to your products, or is it? How does it comply or fit into your current world?
So this is, of course, is a big hype around blockchain. So of course we're also kind of trying to engage with the clients and kind of find at the end what is the business case or the business value in the situations utilizing that technology itself. So we're engaged on kind of various discussions to kind of see, like, is there some type of network effect that we can kind of provide some value to the client base. So I'm still looking for the kind of obvious one that can be connected to the ETRM side. So it's usually like confirmation matching, position matching to kind of save some operational effort on the back office side. But I'm still haven't seen that real business case where I see like that is something we want to spend a lot of our money on. We're looking at the technology, we understand the technology, but now we're still in the process to kind of match the right business case. And that's usually where we kind of engage the clients to see, is there something they're seeing where we can bring some value, but that's then usually a second step to evaluate if blockchain is the right technology or not to support that.
Thank you. Yeah, that kind of fits my expectations, since if you make a connection again to the financial sector, what we see there is that blockchain is at the moment by most actors considered to be sustaining innovation or inefficiency innovation. They apply it in private circumstances, etc., to squeeze out cost sharing potential. And it does not always have to be a disruptive innovation to every business model that's out there. But first, thanks again for your presentation. Andreas will be around for further questions if you like, and we will have a coffee break around 1 hour where you can address some further questions. Thanks a lot.
Thanks.
So let me see here. Then there was obviously an intention with the blockchain question, because I tried to somehow move now from the topic of real-time analytics towards the topic of Gordon Thompson. And I hope now, there it is. Does it work? Yes. As you can see, the topic is adoption of blockchain technology, the energy approach, and there we pick up the topic again of blockchain technology and get the perspective of energy about this. Briefly, Gordon Thompson here on the stage is a portfolio manager with the Energy Innovation Hub, if I'm informed correctly, and he is obviously working on blockchain business models related to the energy industry and machine learning economy vision. Okay, so without further ado, looking forward to your presentation. You have roughly 50 minutes.
Brilliant. Thank you very much. Good afternoon, everyone. It's great being here. Do I have a clicker?
Yeah, I'm searching for it. It was here.
Brilliant. Thank you. Okay. So I'm in Energy, and as many of you might know, Energy our leadership has made a real commitment to digitalization and being a part of the green energy transition. Now, inside of Energy, we have many smart people looking on many different types of technologies, looking at many different use cases. And one of the use cases that we're looking at, one of the small areas, is blockchain, because we see blockchain having some interesting potential. Myself, I work at the Innovation Hub at Energy. Essentially what we do at the Innovation Hub is we invest in early stage technology companies, so it's usually small teams, 5 people with an idea of how to disrupt an industry. We invest in those teams and then we try and support them as much as we can to create operational value. Our portfolio is above 60 companies at the moment, and essentially we're investing in 4 verticals. The one vertical we call Smart and Connected, which is essentially smart cities, smart homes, smart buildings, etc. So it's IoT type technologies. We've got Disruptive Digital, which is any companies that are working to disrupt our core business or the energy business using digital technologies. We call that Disruptive Digital. Cybersecurity is quite important for us as we become more and more digitalized. And then we have Machine Economy, which is where we spend most of our time thinking about blockchain. Now the question is, what do we think when we think of machine economy, or the way we think of it is machine to machine economy, is we have a hypothesis about what the future might look like. At the moment we've got a lot of business models like B2B or B2C or B2B2C, and we believe in the future we're going to have M2M or machine to machine economies. So we do believe we will get autonomous vehicles in the future. We do believe that some of those autonomous vehicles might be on a platform like Uber, and some of those vehicles might pick up drivers and drop off drivers. Now the question is, if you have an autonomous vehicle picking up passengers and dropping off passengers and getting paid for that service, would you need a human to intervene to do other transactions for that machine? For instance, being charged, or getting your tires changed, or going to the mechanic to get something repaired. In theory, in the future, we can imagine that machines will be doing this all autonomously, and we need a layer which can govern what a machine can and cannot do. And blockchain protocols is quite an interesting way, or smart contracts that they talk about is quite an interesting way that potentially could be done. And then also the promise of micropayments, which blockchain provides, is something interesting. So this is one of the reasons why we think blockchain is a relevant space to be looking at, even though it's in the very early stage and can't necessarily be scaled out into some applications at the moment. But we're trying to identify which applications can we scale that into. So when we look at our core business, there are many, many use cases that blockchain can be applied to in theory. There are some issues that slow us down for deploying interesting blockchain business models. At the moment, one of the major ones is the penetration of smart meters. To really get some of the really interesting blockchain technologies or business models to really work, we need far deeper smart meter penetration, which we just don't have at the moment in Germany. And essentially what we're also doing is we're trying to look for use cases, and there's that disconnect between infrastructure and use cases at the moment, that we want to be able to go to 100 miles an hour, but at the moment we're only going 2 miles an hour. And in many cases we haven't even figured out how to do the 2 miles an hour yet. So we're looking for usable use cases where blockchain is actually uniquely positioned to create a value add to a particular operation. We have invested in Energy Web Foundation, which is a blockchain solution. I'm sure some of you may have heard of them. They're very similar to Ethereum, which is most probably the most widely adopted blockchain solution out there so far, using smart contracts, essentially bringing the whole concept of smart contracts to the ecosystem. Where the Energy Web Foundation is different to Ethereum is that they have a different consensus layer. Instead of having an anonymous consensus layer, they have a known consensus layer. And a couple of benefits come with that. One is transaction speeds, and the other one is we know who's actually authenticating transactions, which we're a lot more comfortable with. And These are the affiliates in the EWF network. So these are the companies that would be validating transactions, so it's not anonymous. Some of these companies are actual competitors of ours. However, we do believe they are operating under the same rules and regulations as we are, so they're not going to do anything inside that system that would harm the system as a whole. So that's a model we can trust quite a bit ourselves. So at VestNet, we've been looking for use cases where we can actually start deploying a blockchain application, where it actually makes sense. And one of the use cases we have identified is timesheets. The way a lot of timesheets are still being filled out is it's still paper being sent to a field worker or an engineer in the field, who will then actually fill out his timesheet on a week-to-week basis or a month-to-month basis and try and remember what did he work on, what times, which dates. And then at the end of the month, he'll sign off on that timesheet, and then we collect a big pile of paper, and then someone has to manually enter it into an Excel sheet, which is then eventually finds its way to being saved in an SAP system. And then eventually the auditors come in, they'll go through the Excel sheets, and they'll make sure that things match up with what's on the paper. It's quite a time and cumbersome process, but it's very important because we do take a lot of public money in the form of grants or Fördergelder, and it is our fiduciary responsibility to account for how we are spending that money. But the process we have in place at the moment could be optimized. And we believe blockchain might be an interesting use case for this particular one. Now, many use cases that we look at, we actually discover in the end that just a traditional centralized database is actually the best solution. It's really fast, it's really secure, it's really cheap. No need for a blockchain. But in this case, we want to provide a right-to-only database where we can show to the public and to public auditors that we have only put data onto this blockchain and it hasn't been changed or edited. So this is what we're doing. We're just building a simple mobile application that someone in the field can use and fill out, enter their dates, what projects they're working on. It will be written to a blockchain, and a copy will also be kept on an SAP system. So we basically have a two-ledger system. We've got one copy on the blockchain, one copy on SAP. The auditors can go and have a look at the blockchain version whenever they want. If they want to have a look at the SAP version, they can do that too. And even members of the public could theoretically go and have a look at it if they so found it interesting. And that's essentially what we've been working on at Energy, and that's the very first use case that we're going to be using to implement a blockchain technology. And it seems insignificant perhaps, but what we have to remember that this is the first step towards the next use cases where we will then implement more ambitious business models on the blockchain. Thank you very much.
Thanks, Gordon, for this insights into the current business case evaluations at Energy. Are there any questions from the audience which you might want to raise? Yes. Wait, I need a free hand. I've been waiting for this.
Hi. I got a question. When you were trying to implement certain blockchain projects, what were the major obstructions? Was it a technical side? Was it the regulatory side? The business side? HR side, probably?
So in the early days, so the thing that slowed down certain projects is, yes, how does GDPR apply to blockchain? And GDPR just recently came out, and there wasn't really any guidance on that. But now we've got a better idea of how GDPR will be applied to blockchain technologies and what kind of risk a company has. Even running a node, it becomes quite interesting to understand. So that was one of the things that slowed us down quite a bit. The other one is actually finding a use case that makes real sense. It's an important use case, but a simple enough use case that's confined enough that we can actually test the hypothesis and actually create operational value in the short run and quite quickly. Essentially managing our risk profile on the project. It's quite easy finding very large, very ambitious projects that have a very large risk profile and big chance of actually not working out, but finding something, that first baby step towards That took us quite a bit of time to identify something. And again, as I mentioned, identifying a use case where using blockchain is actually superior to what's currently most people are using, which is a centralized database, because that infrastructure has proven to be quite a good way to do many things, and blockchain doesn't necessarily replace that yet. In many cases, we find. Yeah.
Thank you.
Okay, thanks a lot. Are there any further questions from the audience?
Yes.
Go ahead.
Thank you. Another question. So probably you mentioned it, but I didn't hear it. Share and charge. Is it
Yes.
still in operations?
Yes, it is. It's actually become a foundation based in Zug. It's a completely independent foundation. We've got no control over share and charge. They're going to be doing an ICO quite soon. Yes.
And on which technological basis? So is it Ethereum based or something new?
So they originally built on Ethereum, but as mentioned, the EWF it's actually pretty much Ethereum copy pasted, and they've just changed out the consensus layer. So pretty much anyone who can develop on Ethereum can also develop on EWF. So that's why we have quite a bit of confidence, because Ethereum has the highest adoption rate. We can imagine a lot of developers being able to move over to EWF without much problems. And with share and charge, they're currently they're moving across from using the Ethereum network to using an EWF.
Thanks.
Just a short side remark on that. Share and charge is at the EWF booth and A50N, I think, something like that.
Thanks.
Yes.
So there you get more information on the status quo with a nice e-bike. Okay. Any further questions? There's.
Thank you. Since the morning, I was hearing that blockchain is the future of trading, as the green way. And my question is, the real one, is the blockchain, what is the great advantage, the main advantage of the blockchain right now that will say that is real the future in the trading? What's the real economic advantage?
Well, that's what we're still trying to discover, to be honest. I'd be a bit presumptuous if I said I had the answer to that at the moment. One of the major advantages blockchain does have is at the moment it's incredibly hard to hack, or at least it hasn't been hacked yet. If you look at the Bitcoin chain, it has an incredible amount of value on that chain, and it's an enormous honeypot for hackers to actually go in there and maybe assign ownership to different individuals than ownership should be assigned to, but no one's been able to do it yet. But because of that, the trade-off is it's an extremely expensive infrastructure to run. So from a perspective of being a right-to-only database, that is very interesting. That's an interesting aspect that blockchain has. The other one is that it's got a very robust security infrastructure, and we're trying to figure out how to, or at least developers are trying to figure out how can we maintain that level of security, but at the same time increase transaction speed, which means bringing, changing the consensus layer. And obviously, as we've seen, there's a lot of innovation in that space and a lot of different models that are being worked on at the moment. But that's the main shortcoming that I see at the moment, is transaction speeds are just not fast enough, and it's actually just too expensive per transaction. There's the big promise that blockchain is meant to be super cheap, super fast, and hasn't reached that yet. But that's what they're working towards. But once that is achieved, blockchain does have very interesting, unique properties that will be relevant, we believe.
Okay, thank you.
And if I may add to this, it's important to differentiate what blockchain technology you're talking about. If you're thinking about the advantages of having a public infrastructure that provides you with a framework to execute transactions, for example, in the case of Bitcoin, you have a public infrastructure that allows you to address the double spending problem. And if we have a similar public infrastructure, then this might come with huge benefits, but at the cost of established business models. And The other case then is whether we use private blockchain internally to improve efficiency of processes. And it's very difficult to compare the discussion about private blockchains and public blockchains. It's a little bit like internet and intranet. It's somehow the same, but not really. Okay, so time is running out. Thanks again for your presentation. If you want to catch Gordon, I hope you stay a little bit till the coffee break in half an hour.
I'll be around.
And then you can get him at a coffee to ask your questions on blockchain. Okay, thanks a lot again.
Brilliant. Thank you. Yes.
We won't leave the topic of blockchain now. We will stick to it. And actually, Clemens Wagner-Buschek was the one asking the questions beforehand, which is not a surprise since he will now present on the technological and organizational dimensions of blockchain from a regulatory perspective. I like this discussion very much, which is not surprising because I'm an institutional economist and it's more interesting to see what changes in the industry rather than how the technological details are really. And Clemens is the Deputy Director of Competition and Regulation at E-Control, the energy regulator here in Austria. And he focuses on design and enforcement of market rules in the Austrian energy market and works in the E-Control's economic division on market surveillance RIMT. And before I talk too much about this topic, because I really like it very much, I give you the floor and wait with my answers till later on. So give a nice welcome to Clemens, please.
Yeah, welcome everybody. It's a great pleasure to be back at the European Utilities Week, and after last year's talk on blockchain, I'm not too surprised to be talking about blockchain this year again. I like talking about blockchain, or more generally put, talking about topics of digitalization, of innovation, for mainly two reasons. First, if I look into your faces, I see barely frowns. Yeah? You all look more or less happy, eager to hear what the regulator is telling you. Usually there's some tension between the audience and the regulator. So that's one of the reasons. And the second reason is I think technological innovation can make our lives much, much easier. Yeah? Automation can help us do the work without spending too much time on trivial tasks, but spend our working time, our brain, on much more interesting topics. Today I was asked to talk about blockchain from a regulatory perspective. And, if you think about the regulatory perspective, you should understand a bit about the roles that a regulator is actually taking in the market. So for that, I have prepared a few slides. So first of all, if you think about the regulator, you can think about the regulator as a company. We are a company just like you. We don't have monetary-driven company objectives, but we still have our objectives, our goals, our obligations and rights, and we, of course, want to fulfill those. Second, we need to be observers. We don't, as an energy regulator, or more precisely speaking, as the regulator for electricity and natural gas, we don't only observe natural gas and electricity markets. No, we also observe financial markets, heating markets, transport markets, because they might have impact on the energy sector. So we are observers, and we could have a look at blockchain technology from that perspective. The third part, that's probably, and here I make a stop when I talk about the regulatory authority. The third part is a regulatory authority as a rule maker. We are, to a certain degree, allowed to set rules, to stipulate ordinances, to make the game, but only to a certain degree. The rest, that's what's highlighted here in orange, that's the policymaker. And I've talked to many, many startups in the course of the last 2 years. Many don't understand the difference. We are enforcing rules, we can make certain rules, but the big game-changing market design questions are decided by the policymakers, by the ministries, by the European Commission and so on. But still, within our roles, today I take the perspective of the rule maker, because that's quite something different from what I would think about blockchain as a company. For today's discussion, 4 thoughts. The first one is, I think we need to start assessing blockchain technology, DLT, whatsoever, across objectively specified technological and organizational dimensions. So far, the discussion is around democratization, about enabling the end users whatsoever. But if I look concretely at certain implementations, I need to understand what are the technological dimensions, what is the speed of the transactions, what is the consensus mechanism whatsoever, and also at organizational dimensions, and be clear about which implementation features which attribute in the various dimensions. Second, if we want to foster distributed ledger technology, we need to start demystify the discussion. What I just mentioned, energy consumption of blockchains, for example. If you ask the average people on the street, or even if you talk to people, colleagues of mine, if you go to the ministries, one of the very first things they say is, wow, blockchain technology, that costs so much energy. Which is, as we all know, only true for some of the implementations. So we need to get more and more objective in our discussions. Third, often the challenges that we face when we talk about implementing blockchain technologies or blockchain projects, it's not a question of the technology. We should not talk about the blockchain regulation. We should talk about what is the underlying market design that is required and for which the blockchain technology can be the enabling technology. And fourth, now that's very much the regulator as the rule maker. If we assess as a regulator blockchain implementations, blockchain projects, we need to keep stuck to our well-known regulatory principles, probably put them in a more future-looking disguise, but still keep to those regulatory principles. Now, let me go a bit into detail on these issues. Let's start with the dimensions. So what should we talk about when we assess blockchain projects? First of all, there's of course energy consumption. So we should ask how much energy is required. We should distinguish between proof of work and probable under consensus mechanisms, and should understand what are the advantages from an energy perspective. I mean, probably some of you know, but from an academic perspective, I think proof of work, for example, is still the most worked out consensus mechanism with the best or the only proofs available to certain algorithmic properties that you want to have. Anyway, energy consumption is a big issue. IT security and data protection. We just heard it from the colleague from Energy. Data protection rules are a big topic. They have been in the past, and now with GDPR, it got much more intense, much more work to be done. Concerning the IT security, yes, blockchain technology uses cryptography in a much more intrinsic way than probably classical technologies. But still, if someone tells you blockchain is the most secure technology out there, we cannot be sure about that. It differs between the various implementations, between the various types of DLT technology you're looking at. And actually, saying that blockchains are unhackable, I wouldn't dare to say that. I mean, you know the example of the DAO. If you have a programming error, still that can happen with the blockchain. Another issue, data. So I'm working in the market surveillance team of eControl, at least 40% of my time, and that means basically looking at trade data, looking at transaction data, order data, trying to find cases of insider trading, of market manipulation. And for that reason, some of you might know that quite well, we collect for several years now loads of data, loads of trading data, order data, of fundamental data, injections into the grids, exchange capacity availabilities, and so on and so forth. You might use it as a trader, yeah? And if you look at the data, then I would say the data quality in general can be much improved. It has improved over the last years, but still there are issues. And defining the proper data formats for the exchange of transaction data, for example, and specifying the rules how to submit those, be it that via a relational database, be it via blockchain technology, whatever, that is still a task that needs to be done. Yeah? So some form of standardization, of normalization might be necessary. Talking about data, there's also the question of interfaces. So if we employ now a blockchain solution, how can this blockchain solution interact with our legacy systems, our relational databases? That's something to be taken account of. Or we come later to that again, interfaces to the physical world. Blockchain is very fine in a purely virtual setting, but when it has to interact with the physical world, there are technical, let's call them challenges that we have to face. Practicality issues. So one of the biggest selling points, I think, of blockchain technology is immutability. Once a transaction has been recorded in the blockchain, it cannot be altered anymore. That's very nice probably from an audit point of view, from a security point of view, but on the other hand, what if you made an error? What if there's a legal provision that requires you to be able to unwind the contract within a certain period of time? then blockchain technology, or in this form, is not so favorable, and we need to find a way to work around this challenge. And now, that were rather technical issues, and I avoided the question of scalability because I think that is something we hear in many talks about blockchain technology. Coming now to flexibility. Blockchain, it's pan-European, it's technology which can be used across the world with lots of initiatives. That can be the Energy Web Foundation or many others that are trying to build an ecosystem for blockchains basically fit for the whole world. But nevertheless, across each of our countries, we have local specialities. Those might be regulatory nature, those might be market-based, or whatever. We have local specificities, and we need to take those into account. And the question is, can this blockchain technology, is it flexible enough to take into account all these local specialities? And now you might say, yeah, we can create sidechains and sidechains of sidechains, might be well, but in the end we need to evaluate, are the advantages that we see compared to the traditional systems, are they still there if we take all these real-world issues into account? Roles, one of my favorite topics. If we look at a blockchain, classical Bitcoin network, we have the nodes that are able to verify, that are able to initiate transactions and so on, and we have the mining nodes. So basically those who create new Bitcoins, those who are validating or mining new blocks. It needs to be clarified in each application, especially if we're talking about blockchain applications which shall deliver electricity, gas to the end consumer, to us as private people. We need to be sure which roles do we take in this blockchain, who is taking which roles, and what are the responsibilities, what are the rights, and what are the duties of those roles. And that is kind of connection to the governance issue, who is allowed to take which role. But before that, trust. It's always claimed that blockchain technology solves the trust issue. I fully agree to a very limited extent. The trust issue, when we do some trading in a virtual space, that's fine. Blockchain can take care of that. But once again, if we have an interface with the real world, take for example, your private PV panel feeding in electricity to the grid. It's nice if there's some gadget, some computer that is writing data that produced kilowatt hours into the blockchain. Once it's in the blockchain, once I trade those kilowatt hours in the blockchain, that's fine. But who guarantees that what this computer writes into the blockchain is actually correct? So there's an interface that needs to be taken into account. And there we still have a trust issue. Same with many, many other commodities. Another trust issue, what about pre-settlement risk? If I start trading, let's say, futures on a blockchain, who takes care of the credit risk? I mean, there's still value in having exchanges at the moment, but probably some of you already have good ideas how to overcome that issue. And then finally, the decision structure or the governance model. I'd very much like to know, for all the blockchain projects out there, for the implementations, who is actually taking the decisions? How are these decision processes designed? And do we really have a decentralized voting power? So do we really bring power to the people out there? Just imagine looking at a peer-to-peer energy trading system where each one of us can participate. You with your houses and the PV panels, probably you have a flat and some PV panel outside of your balcony whatsoever. If there's now a decision, like we had for Bitcoin just some time ago, to increase the block size, for example, which is a purely technical decision, do you as private people, do you feel empowered to take a democratic decision in here? Of course you can vote yes, no, but do you really understand the underlying technology? And I say yes, we here might be able to understand it because we've been working on that issue for several days, hours in our lives. But the average people out there, I would say no. So is it really democratization? I don't think so. Anyway, let's turn to the objectivity and demystification, and I think most of those issues I've already raised so far. First of all, there's still a big misunderstanding when you talk to people. Blockchain is not Bitcoin and DLT is more than blockchain. So we really have to understand Bitcoin, that was the very first instance, it has its drawbacks, it has its benefits, but there's more to it. But talking to politicians, talking to some utilities, talking to private people out there, they still identify blockchain with Bitcoin. So that's something we should tackle. Moreover, are blockchain solutions as we know them nowadays, are they really the best we can get? There are lots of other DLT initiatives, be them IOTA, be them Hashgraph, whatsoever. And I know all the discussions about the pros and cons. That's fine, we're still in a research phase and we need to identify what is the proper technology or what is the best technology for the future. It might well be that one form of blockchain or DLT is fit for certain areas, let's say in the IoT area, whereas another solution might be better for peer-to-peer trading or whatsoever. Again, the energy consumption. We talked about it already. I think at the beginning of the year I made a rough estimate of the energy consumption of the Bitcoin network, and it was around the electricity consumption of Austria, something like 70-75 terawatt hours. I don't know the current figures, but I think they are even a bit more, albeit they slowed down. Anyway, we need to tell people and to promote that other technologies, other solutions do not have the same energy consumption. The trust problem. I think I addressed it already a lot, so I'm not going into details here. Who makes the decisions? If you talk to various initiatives out there and ask them about the governance model, actually, it's some of the very, very last issues they solve. The tech is easily there, the business side comes, but then who is investing what money and who is allowed to take which decisions? That's the big question that usually, at least in my experience, remains until the very last. Are blockchains really more secure than traditional solutions? I mean, I don't have to tell you. You access your money, you access your smart contract managing your PV panel whatsoever via your private key. If you lose your private key, if your laptop gets hacked and someone takes your private key, that's gone. So it's fine to say, yes, cryptography is intrinsic in that, and that's fine. But don't tell everybody it's much, much more secure than anything else. And finally, are blockchains totally decentralized? Yes, even a Bitcoin network, you have millions of nodes. You have even a big number of mining nodes out there. But if you look from an organizational, from a logical point of view, it is very, very much centralized. There's a very simple logic. I'm not the IT expert to judge that, but that might be a drawback in the future if you have one system spread across the world and the logic is very, very simple and it's very, very much centralized. Now the third issue, something I think is very, very important. It was one of the examples which should allow blockchain technology to become reality. Peer-to-peer trading. Just a few weeks ago I had several workshops on blockchain technology and regulation, and I asked people, what do you mean by peer-to-peer trading? I know most of you will have an idea what you mean by peer-to-peer trading, but back at those workshops I had 3, 5, 6 different opinions what is actually meant by peer-to-peer trading. Some people in Germany, in Spain, they already use peer-to-peer trading system, but basically because they have some utility acting as a kind of regulatory umbrella for the peer-to-peer trading system, which was for some people fine, for other people that's not peer-to-peer. Anyway, the question we want, wrong direction. The question we have to tackle is, what is it really that needs a regulatory attention? Is it a technology? When people claim, yeah, we need a blockchain regulation for the finance sector, for the energy sector, whatsoever, or is it a question of market design? And that, for example, for peer-to-peer trading, that's an issue. If you look nowadays in Austria, for example, look at peer-to-peer trading. Let's assume I got a house, have a PV panel, and you are looking at me, so I'm selling you now energy via my peer-to-peer trading system whatsoever. If I look at the current regulation, I would take several roles. I would be a supplier because I'm delivering electricity to you. I would be a producer because I have a PV panel. Would be a small one, but still I would be a producer. I would be someone feeding into the grid, which is a technical role I also take. I could even be a trader, because what if I even have some home storage and then I start probably selling electricity at a later point in time, not directly delivering to someone else, but selling it on an exchange, which still might prevail. Or what if I sell the flexibility in my house? So I might be a trader. And of course, I'm a consumer. It might still be that I take electricity out of the grid to use it in my house. And once I take all those roles and I look at what I have to do nowadays, there's a plethora of obligations you have to take. And I have to say right at the beginning, it does not prevent peer-to-peer trading. It might render it non-economical, or it might make it really burdensome, but it's still possible. You might have, in Austria, you would have to set up or join a balance group. So some entity, some virtual entity again, which takes care of your imbalances. You would have to, if I'm a supplier, and I'm living, for example, here in Vienna, and you are living, let's say, in Vorarlberg, in the western parts of Austria, then I would have to register. You're not from Vorarlberg, no? Okay. I would have to register in Vienna with the local government and in Vorarlberg, for example, and say, hello, I'm a supplier. Yeah? That's something you have to do. There's also something called supplier switching. So he needs to be able, of course, to switch supplier basically whenever he wants. But if we do the peer-to-peer trading, he would be switching supplier probably on a let's say 50 minutes basis. And nowadays there's the obligation, yes, switching a supplier need to be or must be done within 3 weeks. So 3 weeks, 50 minutes intervals, that does not fit together. You have potentially, once you're trading, you might have to register as a market participant on the remit, the Regulation on Energy Market Integrity and Transparency. So we as regulators might have a look at you whether you're manipulating any markets or doing some insider trading. Probably unlikely with a singular PV panel, but you never know. You have to prepare and publish general terms of conditions for you as a supplier. And most importantly, probably you have to pay as a consumer and as a producer your network tariffs. So that's from an economic perspective probably the biggest obstruction. Nevertheless, you could do it. And some people avoid the unnecessary burden for the end consumer simply by being a utility, having a balance group, taking care of all the GDC conditions and so on, and acting as a kind of regulatory umbrella. Is that sufficiently peer-to-peer for everybody? I don't know. A question we need to answer. So, what level of peer-to-peer trading do we want? And are we willing to change our market design? And I think that is something we would have to do, because if you look at those regulatory, I wouldn't call them barriers, but the current rule setting, it's still focused on the old centralized world. The question is, do we want to move towards this more decentralized market design? But once more, whether I implement this peer-to-peer trading by blockchain, by hash graph, by a relational database, that's something completely different. It's the enabling technology, fine, but that's not what we are looking at. Okay. Then finally, regulatory principles. So at the very beginning, there are the regulatory objectives. We have to enlarge competition in the markets. We have to take care of security of supply. We have to design sustainable energy markets and so on and so forth. Just have a look at your preferred European energy regulation or have a look at the so-called e-control law, then you can see all the objectives that we have to reach as a regulator. And those have to be maintained. We should be technology neutral. Even, as I think from a logical point of view, as I just said on the previous slide, it's logical that we are technology neutral because we are talking about the market design, about the rules. We are not talking about implementing technology. But even apart from that, whether it's a blockchain, whether it's hash graph, whether it's, I don't know, some Microsoft, Amazon, whatever service database, I don't care. Another important issue, business case or business model neutrality. 2 years ago, I was on a conference in Cologne, and there was someone on a panel from a, well, let's call it a startup, and he said, yeah, I think it is necessary that regulators offer free consultancy services to small startups and companies. Because, and that was what he said, we want to get rid of the big players, which is far away from the truth. And why should we distinguish between our market participants? We want to foster competition, right, but we cannot simply selectively support certain startups. Anyway, we should be neutral in that respect. Very tricky. Clear and stable framework. I mean, you all experience it. The speed with which digital innovation happens is increasing. Now, what should we do with the regulation? If we increase the speed in regulation, there's the danger that we are acting too fast, that your investments are not in a regulatory secure environment. But on the other hand, if we are too slow with taking our decisions, there's the risk that some startup, some new company pops up and acts, let me call it areas of grayness in regulation, where they basically become a kind of incumbent in this new business case. So that's tricky. And harmonization and standardization, I think I mentioned this once or twice. I still believe it's very important that in all our data exchange formats, in whatever, in the new market design, we try to find a harmonized way of how to interact with how to let data entities interact and specify the appropriate interfaces. Just a tiny remark, some of our results we put up as a working paper, at the moment still in German, but the English version shall be available soon. And probably a final thought, I'm standing here as an energy regulator, or a regulator for electricity and natural gas. But, and that's a big issue I think for the market players out there, for the startups both as for the utilities, there are many more regulators, especially nowadays with blockchain solutions. If you ever use your token as some kind of payment service, if it gets the character of a financial instrument, now in a very broad sense, you have to talk to the financial regulators. There might be cybersecurity issues if you employ blockchain technology in critical infrastructure. There's the question of probably talking to the regulator of communications or for the power and IT sector. There are questions of consumer protection you have to ponder. So it's not just me as one regulator, we are a whole bunch of them, and that's a special challenge for us as regulators, I think, that we start to interact and see the broader picture to be great contact persons to the market participants out there. So in this sense, thanks for the attention, and I hope you have some questions.
Thanks, Clemens, for the very interesting and a little bit, is that word existent, hype-reducing presentation on energy and blockchain, which is very important, and I think kind of reflects the current situation we are in general when it comes to blockchain and the energy sector, where we passed through, hopefully, the peak of the crazy hype, and where we start to narrow down the discussions to developing the answers to the fundamental questions we have to raise firsthand. Do you have any detailed questions to Clemens you would like to raise? There it is.
Do startup teams actually approach you as a regulator for advice on regulation?
Yes.
Yes?
But I mean, I don't know if you have ever interacted with e-control before, but we have some kind of people taking care of market entrance in general. So there are people who take care of those who want to enter the Austrian market, for example. We have some papers online where you can get a quick understanding of what, for example, if you want to start being a supplier or a paper trader whatsoever, what you have to do. But that is just a general service. Of course, we got offers to participate in several projects. But as a regulator, I mean, that's a bit of a tricky question. It's fine if we're kept in the loop. It's fine if people address us with questions. Do you think is that, from a regulatory perspective, fine? Does it make sense? Then that's something we are there for, yeah. This is kind of advising role, but that's open to everybody. But yes, startups are approaching us. And also utilities.
Okay.
There's
nobody's throwing it.
How well are the regulators in the CVE area are cooperating in this to increase or to, let's say, introduce blockchain into regulations? As that's the biggest common market across country borders at the moment.
Let's say, I don't know, how did the blockchain technology pop up into your companies? My experience is, I looked at it from a trading perspective. Colleagues of mine looked at it from a smart grid perspective, for example. Others rather from colleagues from a financial regulation authority from a financial perspective. I guess it might be similar to your company. And it's like that in the CVE region or with all our other regulators across Europe and even across the world. So there are several smaller groups that have been tackling this topic, for example, from a remit perspective. What is kind of blockchain-based trading system from a market surveillance perspective? What should we, how should we call it? Is it kind of an exchange? Is it kind of a PPAT? Whoever knows that term, and so on. So we have loose groups that are interacting more or less strongly, but what is still lacking is kind of big unified approach. But that is something which has been identified and which is addressed. For example, you might have heard of the CER, so the Council of Energy Regulators' new strategy addressing topics of digitalization. And one of the main issues is blockchain DLT technology, where it is planned to have an exchange on a completely pan-European basis.
And maybe to add to this, I think it would be unpolite from you to say that, but and I won't say it as well, but just give the hint. Search for such position papers as they were published by e-control on blockchain technology and the other regulators. That probably answers your question. That won't be many. Okay, any further questions? I have one, which is rather general, and I don't expect a clear answer. but I want to stress the time perspective we need to discuss, because I think, and I totally agree, that from an institutional regulatory perspective, the market design is the interesting thing, and we don't need to care about which DLT it is that is the foundation for this market design. Under the assumption that a DLT would pop up where we say, okay, everything is clear, which will probably take some time, at best guess 5 years, maybe 10 years. How long would it then take, from your perspective, to change the market design, to make the market ready to make use of the technology? Because as long as we don't have a change in the market design, that's a market entry barrier for this technology, basically. So, just a feeling.
So, tricky question. I could simply answer and say that every 10 years we have an energy package, so that could give it a time frame. I think it depends a bit on how you employ this new technology. As you mentioned before, for me, in principle, there are two types of blockchain applications. One is simplify existing processes. That's something like having a wholesale trading system based on blockchain. That's one thing, which still needs some probably regulatory allocation within the rules. And the second thing is having something like redesign a market. So the first thing that should happen rather quickly, because that might even be decisions which are taken on a national level or, let's say, on an ASA level. The other one, that's European Commission, that's European Parliament, that takes much, much longer. But I think we are already starting. I mean, with the clean energy package, the first steps towards a more decentralized world. But still, every 10 years we have a new energy package.
Okay, thanks. That was actually kind of the answer I was expecting. It's important to keep the energy time frame into consideration when we talk about blockchain, especially if we talk about changing the way we do energy business under the assumption that there is a blockchain technology we would like to use for that. Even in that case, that won't happen fast. And the perception in the public discussion is that it will happen fast. That is true for different markets, not for established markets. And okay, maybe one last question, and then we move to the coffee break.
Do you as a regulator here in Austria think about how technology teams or technology companies think about regulatory arbitrage? We make quite a lot of investments into blockchain companies. We have to be quite cautious because sometimes those companies choose to incorporate in places like the Caymans or the Virgin Islands or somewhere like that, where we feel uncomfortable investing in a foundation located there. But we notice that a lot of technology companies are choosing to choose jurisdictions where they see nearly a sandbox, and these jurisdictions can obviously maybe they'd be positioning themselves to basically benefit the most from these new technologies, because that's where those teams are choosing to incorporate. Is that something you think about?
Of course, I mean, regulatory arbitrage, that's something we try to avoid. The issue is how to track that, how to monitor that, and that's very tricky. I mean, in the blockchain sector, it's okay as long as it stayed quite small. You could watch it, have a look at the various projects. I wouldn't say that's feasible nowadays, at least for one person. We try to connect to our co-regulators to see they take care of their country, we take care of our countries, and compare. But still, that could be improved, but it's a matter of time. And as you might know from Energy is an innovative company, at least you specifically designed the department for that. But for us, it's still a topic which has to be worked on aside several other traditional topics. So it's not that we have something like a digitalization department or so. So it's a question of time. And so we're basically, we need to discuss a lot with market participants, with our co-regulators, and hope for some lucky whistleblower in that respect. But we also have to say, I mean, in the energy sector, it's less likely at the moment, I would say. Finance sector, that's something different.
Yeah. Thank you.
You're welcome.
Okay, so I still have a couple of questions, but I will move them into the coffee break. Everyone else, you are invited to ask your questions to the speakers who are here at the floor, and we will proceed within half an hour. At 4, we start with the next presentation. Here, then again, moving for one presentation away from the blockchain topic towards how to combine different data sources to develop a basis for data analytics. And after that, we go back to blockchain. Okay, so see you soon. Once again, good afternoon, ladies and gentlemen. For those of you who haven't been here beforehand, my name is Marius Buchmann. I'm the host of this afternoon session on innovation in trading. And we have heard so far a presentation that focused more on how to get the data sets right as a basis for algo trading. And then 2 presentations that focused more on blockchain and its implications for trading. And now with the following 2 presentations, we focus again more on the current potential of digital innovations in trading. First, we will hear a presentation on algo trading and more drivers and trends. And afterwards, we will hear a presentation on the potential of the combination of different data sets as a foundation for algo trading. The upcoming speaker is Andreas Schwenzer. Mr. Schwenzer is the leading energy markets trading and risk management, leading the energy markets trading and risk management activities at Howard & Partners in Hamburg. And his focus areas are strategy and business model development, as well as digital transformation. And he will present on algo trading and more drivers and trends. I'm really looking forward to your presentation, and the floor is yours. And please give a nice welcome to Andreas.
Yeah, thank you. Can you hear me okay? So, will we all be using electricity in 5 years' time? I think the answer is presumably yes. A different question is, will we see people sitting on the trading floor trading short-term energy markets in 5 years? Our view is not. So our hypothesis is within the next 5 years, energy trading will be almost completely automated. So what are the reasons or the drivers for this? Firstly, we see volatile price changes, extreme price scenarios, and this will remain and will even extend due to renewables feed-in. We already had the discussion about rising trading volumes, and this is a scenario where algo trading can help. The next aspect of this is the increasing trading volume. Then, and I think this is also an important aspect, and we didn't touch this before because we have been mainly talking about the cost perspective of this. But the number of market participants who are using automated trading will increase to a level where humans cannot compete, because if you are sitting in front of the screen and you are trying to trade the next 24 hours in quarter hours, it's 96 quarter hours for a couple of markets, and you have 500 different prices in the front of you, and you cannot, as a human, capture this and take the right decision. You need support of a machine for this. And then last but not least, big data and data analytics will become the key for success to distinguish from competitors. So it's moving away from having the right people actually sitting at the trading desk, is going into the direction having the right people knowing how to apply data analytics and market analytics. So in summary, in 5 years, the fully automated energy trading factory will be a reality. So, looking to the technology perspective, what are the facilitators for energy trading developments? So, firstly, and I think that's also an important point, we have been talking about the matter of speed already this afternoon. The interfaces for algo trading to exchanges are quite important, and they are coming more and more, starting with the power markets, also extending to the gas markets. At the one hand, at the exchanges, and at the other hand, also from the different vendors that are offering solutions. Then, secondly, intelligent automation. Automation of processes by using intelligent software. Examples for this is software robots using operational software like ETM or EDM systems and doing tasks that are currently done by humans by applying rules that are predefined and can be automated. Then thirdly, which is also an important technology point from our point of view, in-memory data storages, like, for example, new database technologies like SAP HANA, which are enabling the processing of huge amount of data and data lake approaches. So when we are looking back 5 years' time, every data and reporting project was quite painful from a performance point of view, and with these new technologies we can also overcome those performance issues and can really focus on the data itself and make sure that we have all data that we need, be it internal data or also external data from other sources available and can process it. And then lastly, intelligent decision support. I mean, algo trading is just one, let's say, form of this, but be it the algorithm that is trading itself on the short-term market, or be it an algorithm that is supporting the decision that is taking in long-term markets or in more complex products. There are really significant developments that can be used in the trading space and are already used in many trading departments today. So, looking to other industries, the banking industry is in many aspects a front runner to the energy trading industry. So we have some key facts also in the banking industry. Cost pressure is one. Large banks, because it's also capex intense, rely heavily on algo trading, mainly in asset management and high frequency trading on client services. In equity market, rising presence in other markets, and the use of big data gives rise also to artificial intelligence, machine learning, and deep learning. So, looking to the examples, you see the who's who of the banking industry in the use cases: Deutsche Bank, Goldman Sachs, Credit Suisse, JP Morgan, and Barclays. So that's also a topic which is in the banking industry of high importance. So, moving back to energy. What do we see? What are the key parts that are changing in the space of AI? So, firstly, it's machine learning. So really the development of and use of self-adaptive algorithms that are allowing that the machine is developing things itself with applications, for example, in the front office, in the area of trading strategy development, portfolio management, market access, but also in the back office for deal validation, confirmation, market data, and reporting. Then secondly, artificial neural networks, so systems that are basically building the brain of people, if you like. I mean, many of you will know this topic, so that's around for quite some time. We did the first project with this more than 10 years ago, but that's also strongly developing and more coming into practice. Mainly similar use cases in the front office area and also in the back office area that could be supported by artificial neural networks. And then the last point, robotics. Robotics is also quite important topic that is in use also for customer service processes, for example, in banks where we implemented such type of solution, and they can be used more and more also in the energy trading space. I think the most important things for this are classical back office tasks that are done today to a huge extent manually, and you can go with this to the next stage. So you have today an electronic order confirmation matching. So if everything fine, not a problem. But if not everything fine, a human needs to look into this. And there are, let's say, for the second level support, many use cases where you could easily let a robot answer the questions that are there. So to really capture the full potential of AI, we think all aspects and the whole landscape has to be taken into account. So it's starting with system sources, then all the things that are important regarding data, the underlying model, the applications like trading interfaces and reporting and analytical tools, as well as, at the one hand, IT and infrastructure, and at the other hand, and this is also quite important, so from our point of view, that it's not just a technological topic, it's in many cases also in change topic, process and organizations. And I mean, we had discussions, especially in the area of algo trading, in several occasions. So who is at the end of the day taking the trading decision? Because I mean that's linked to the discussion we already had earlier with the regulator. At the end of the day, somebody needs to be accountable, and there are also in this area quite a few questions that are not yet answered. So what's important to be successful? In our point of view, it's data richness, quality and speed are the preconditions for excellence. And that means I have requirements regarding data analytics, then big data, also, as I said before, really was the point not only using internal data, but also finding the possibility of integrating external data in the analytics, and then the point of automated decisions that are made based on this. So to summarize again, it's speed, data accessibility, proven methodology, robustness, which is also quite important point, and reproducibility for the use cases. And here again an example. This is a use case that was implemented in the HANA technology, where we are doing quite a lot cross industries and for different use cases. And in the trading space, this is just picking up, but in our point of view, will be an important technology in the future. So, and with this trading model, which is coming together with AI, we will have different stages. So the first stage is an automation of manual trading strategies. So just the machine is doing a strategy that is manually defined. Then the second point is that the trading strategies will be developed based on AI, but still will be controlled by humans. And then the last point, or the last area of development, is just there's a risk control framework, and it's quite important to know what the black box is doing and to be in control of your positions and so on. But the decision itself will be automated based on AI and big data. So, and looking again to the cost perspective I mentioned before, this will be also important from a profit perspective, because people just speed-wise can't compete with the machines. But from a cost perspective, we also made a case with a client for the example of power intraday trading. So comparing human traders, continuous trading 24/7, and there are five people required to this, and this is really the lower end. So we know in cases where there are six or seven people required to perform this, and compared this at the other hand with auto trading, where there are also traders as administrators of the solution and developers of the strategies are required, but only two. And looking to the cost perspective of this, you see a really clear picture that the case for automation in intraday trading is clearly there, just taking the cost perspective into account and not the perspective of what could the automate do in terms of outperforming the humans. But we know clients that have this in operations and know the benchmarks. So in the front office, they are really outperforming the predefined benchmark strategies. So that's in general the point. So some thoughts from our side and our perspective, but we also have some views from the industry, and I will close with this. So, for example, we've talked to Andreas Ewert, who is leading the quantitative department at Uniper, to this point, and he basically says that advanced analytics and alternative data sources play a vital role in decision making. I think in the same direction goes Markus Bokermann from Vattenfall. He says it will become a cornerstone for successful trading decision. And then we have an auto trader trading case itself. So Mr. Luxa from CityWorks, head of trading, says so that the auto trader is really a valuable and reliable colleague that are supporting them in their daily business. So yeah, thank you for listening to the presentation. Hopefully we will discuss afterwards, maybe at the traders party this evening, and I think we have some time for questions.
Thanks a lot, Andreas, for the presentation. We have time for one question, and then we have to move on to the next presentation, but Andreas is around to take further questions. So please, there, where is the mic box? Oh, it's there.
Thank you very much for the presentation. My name is Adam from Aksenerji, Turkey. In Turkey, we are also doing some algo trading in intraday market, but I watched like 3 or 2 presentations about algo trading here in European Utility Week. So what I can't really understand is that during the algo trading, we are writing some code, some rules to execute the trade, but how do you put AI, artificial intelligence, into the algo trading? How do you integrate it? What sort of things that you are doing? I really couldn't see any examples of it. So I would be really pleased if you can give some examples. How do you integrate the AI into the algo trading? What's the role of it exactly? Thank you.
Yeah, thank you for the question. So the role of AI in this is basically the development of trading strategies. So it's used to support the market analysis and to draw the conclusions out of the patterns that are seen in the market, and then directly transfer this into algorithms. So it's a step further than just saying the automate what are your rules. The automate is learning its rules itself. So that's the role of AI in this.
Okay, thanks a lot for the quick answer. All the other questions we need to move to the traders party, where the different beverages will probably make him even more keen to answer the questions. So then let's move to the next presentation, and actually Andreas gave a really nice quote, or a really nice statement that introduces the next presentation, when he mentioned that, and I don't recall the exact word, but that excellence requires data availability, data quality, and this is actually the core of the next talk, which will be given by Francesco Acchi, who is the founder and CEO of ARC, and he has a background in financial and energy markets development in different IT companies. ARC is currently located in Ireland and Italy, as I've learned, with private headquarters soon in France, I learned. And Francesco will talk about quickening time to insight. What it means, he will introduce it to you, so please give a nice welcome to Francesco.
Thank you. The screen's gone blank. The screen is blank. Well, while we sort out the screen, in the interest of time, I'll just introduce the talk. I'm going to share with you some of our experiences in the context of managing data for trading and making data available for trading models and for other industry processes from a variety of European data sources. Presentation's coming up, so. Thank you. So I suppose this is the forward button. Okay, so being 20 past 4, I thought we'll keep it a little bit more light-hearted. So in our experience, the key, well, there are 4 main areas that are issues in leveraging data from a diverse set of sources across Europe in order to base trading models, in order to automate processes, in order to feed algorithmic trading. The first issue is the data hoarding dilemma. I mean, there is a budding data scientist there or a trader there. And one of the issues is, how much data do I keep? Where do I put it? I remember talking to the head of trading in one of one of the client organizations that we work with, and we started talking about the data that he wanted to keep, and it was market fundamentals, and then it was meteo, and then it was production ramps, and then it was prices, and then it was tick level data. Eventually, he just said, I want to keep it all. I want a repository. I don't know what I'm going to do with it. I mean, I'm going to initially use part of it, but I might need it in the future. I might need it for bug testing. I might need it for forecasting algorithms that I don't know about yet. So there's a tendency to try and hoard data, which is good, but gives us a challenge of where. So traditionally, if we keep it in a structured form, queryable online form, it creates cost, and it also has a high effort from an IT perspective to model. You can keep it in cold storage. I suppose data lakes are a warmer version of cold storage. They've been popular for a while. In 2017, there's been quite a lot of failures of data lake projects, or projects that are not really seeing the light. They've been called data swamps. I don't subscribe to that point of view. I think they're affected by the frozen data lake syndrome. So the data is not really usable. It needs to be thawed. It's not being prepared for utilization. The second area of difficulty that we've observed is the metadata conundrum. So the problem that we've seen across diverse data sources across Europe is that metadata is either hidden or inconsistently marked up. This is across public and private licensed providers as well. So you may get metadata hidden in the file name. So you may get an FTP service and the file name contains metadata. Metadata may actually be implicit. So the time zone is implicit because you're getting it from that market, but it doesn't say anywhere. The unit of measure is implicit because you're dealing with that type of data, but it doesn't say it anyway. In a lot of cases, metadata is inconsistently marked up. There is no effective cross-provider classification of data. So if I want to work across a number of public and private data sources, how do I find it? How do I categorize it? And how do I search it? And ultimately, how do I capture the user point of view of the data? So what is my taxonomy? What taxonomy in my company I want to use for trading, for back office processes, for different views of that data? I'm sorry, I drew this last night on an iPad, so I apologize for the artwork. But okay, excursions along the time axis. Typically, data that is of interest to trading and also to a number of other processes in utilities is in the form of time series, or is time serializable. It also needs to be transformed for different purposes and for different models. It comes from sources at different levels of granularity. Some of it may be hourly, some of it may be monthly, some of it may be daily, 15 minutes. I mean, with more smart technology, we're going down the granularity. And when I want to use it, maybe in an Excel spreadsheet or in a model in MATLAB or in R or something like that, it's so misaligned. So we need to transform it. So I need to be able to do time granularity changes. I need to be able to shift time. So if I want to look at gas and power together, the gas day is different from the power day. I need to be able to align them. These are commodity transformations. They're very simple, but they still need to be applied. And a lot of companies implement this stuff over and over again. Or I may need to look at tick level stream and sample it at a minute level, and then create a tuple. So a time series of high, low, mid, volume traded for further processing, to feed an algorithm, or even for fiscal reporting, for transfer pricing reporting. And this is the fourth area, the Cambrian explosion of data. So as we move along towards smart energy, as has been defined, more data sources are coming online, more data is coming online. As we apply algorithms to data, we generate more data. Generating more data is both useful, but it's a problem because we need to deal with it. Hence the data scientist there, it's running away. So I'm going to use a quote that is well known. I mean, this from Clive Humby back in 2006 in the context of the different sector in the Tesco Club Card concept, where he said that data was the new oil, but he also said that in order to use it, you need to do something to it. You need to break it down and you need to analyze it. I'm interested in the first part, breaking it down, preparing it. So I think analysis is a value-added activity from the person that wants to use it. So from the trading flow, I mean, they're proprietary models, but the preparation is not. So if we continue with the metaphor, I mean, if I want to drive to Vienna to attend the Utilities Week, at the moment, I mean, I got data there, it's a bunch of crude oil, and I got a car. So to proceed, I have a number of choices. A lot of them involve buying tools, buying bits and pieces to build my own refinery, and then to operate my own refinery in order to power my model and drive to Vienna. So my goal that was drive to Vienna has actually shifted to cleaning a whole bunch of data. And that takes a lot of time, and it's time consuming. Doing it across a large number of data sources, across a large number of providers, is not only a technological challenge, it's an operational challenge. Recently, 2 weeks ago, the Utility Day in Milan, on a discussion panel, there was a data scientist from Repower, and he said something that struck a chord. He said, the perfect day for me is a day when I write the perfect model with perfect data that comes into it without breaking it, because it hasn't arrived, it's broken, it's dirty. So out of all this, we decided that we spent the last 4 years in research and development in writing a system to enable people to use data readily prepared, so to offer data preparation as a service without having companies rewrite the same data processing algorithms in order to feed their models. And we based it on these four axioms effectively. We believe that it's important to consolidate all the data sources into a repository that allows you to mediate access to data in a homogeneous form. We therefore conform all collected data by homogenizing it against 3 types of time series at the moment. One is an actual time series, so for example a series of spot prices that has one version of the truth, and you extend the time series as more prices become available. Version time series that has multiple versions over time. Forward curves derives from market closures or even meteorological forecasts. You will get multiple versions for the same time horizon. And market assessments that are effectively samplings of tick level streams. So a transformation of a tick level stream, a set of events, into a time series. And with these 3 objects, we can then power Excel spreadsheets, we can power statistical analysis models, we can power machine learning algorithms, forecasting algorithms. Some clients are using it to even store the parameters underlying offers that they made to large energy producers. So it's a reasonably flexible system, and it's a service. So there are economies of scale as more companies adopt it, then more adapters get written, and operationally they become cheaper for us to support. What have we done with it up to now? So I mean, you can power dashboards. The dashboard here, so it's a little bit small, but it's a Power BI, so it's a standard Microsoft tool that's looking at P&L of cross-border auctions across Europe. I mean, a few clicks, you drag it into Power BI. Well, You put the queries into Power BI, and then you design your dashboard. You can interface with Excel, as I said, with usual statistical analysis tools such as MATLAB, Zara. We powered a joint venture that launched in 2016, which is an information portal for energy for Italy, k4view.com. So it's this dashboards here that analyze the European market. So we're excited about the technology, and we wanted to come and tell you about it and also share our experiences in the past. If you want to find out more, we're just over there. Thank you very much.
Perfect timing. Thank you, Francesco, for the very nice presentation. And just a side remark, if those drawings are what you produce while you are traveling to a conference, then your art capabilities exceed mine by light years. But again, that's true for 99% of whole humanity. But nevertheless, was a very interesting presentation. Are there any questions from the audience? If that is not the case, then I have one, and we have discussed that beforehand. To me, it seems like the whole framework that you have developed is not only limited to the energy sector. So is it applicable to other sectors? Are you expanding in those directions?
It is applicable to other sectors. I mean, energy is our core background, so we're starting with that sector. Within energy is also applicable not only to training, but maybe also to trading, but also to back office processes, for example. Yes, we might be looking at other areas that have a requirement for standardization. One potential areas of utilization for the framework is also for data distributors. So people that want to supply data in a standardized form to use a system that makes it easier to distribute it.
Okay. Thanks a lot. Since we reached the time for the next presentation, thanks again, Francesco, for the presentation.
Thank you.
Are you staying a little bit longer today? So if someone has a question, just reach out to him or his colleagues at ARC. I think the booth is somewhere around there.
Is the colorful one there?
Yeah, you see exactly. Yeah, there it is. And reach out to him and his team for further questions. Thanks a lot.
Thank you.
So now we come to the last session of today's Innovation and Trading Hub. And to me, this is a very special part of this afternoon, since last year I had the honor to join the first electricity or to moderate the first electricity and gas trades via the EnerChain, which is one of the more popular blockchain applications in the trading business. And today we will have not only Michael Merz, who is the director of Ponton, the inventors of the EnerChain blockchain, but a couple of colleagues of him as well, who will give you their view on the EnerChain project. And without further ado, I give the word to Michael and his colleagues. Enjoy.
Thank you, Marius. Good afternoon, everyone. This is the last session. This is a little bit of an extended session. So I will give my presentation on the EnerChain project, a little bit also on other aspects of decentralized trading using the blockchain. And then after my presentation, we will have 3 very short co-presentations from our colleagues within the EnerChain consortium, which will be in about 20 minutes. So decentralized energy trading, so there are probably hundreds of projects across Europe doing this. Most of them focus on local peer-to-peer trading. And most of them come with the idea of having prosumers and consumers selling kilowatt hours from the one side to the other. Our focus is a bit different. We are on the wholesale side. So in our case, in the case of Enerchain, it is forward products, it is gas or power, it's also spot products, and it is decentralized, which means that we use blockchain technology in order not to use a central hub or a central venue or a central platform, but instead the grid, the network of distributed nodes which exchange data, which exchange transactions, and which use the block forming technique in order to finalize and validate transactions that take place over this blockchain. So just a short overview, because the presentation is about from wholesale trading to the neighborhood, yeah? And just taking this as an overview, where does trading make sense? Trading of energy products, yeah? I will talk about mainly Enerchain, so that's the basic part. That is wholesale, that is the large volumes, that is a couple of megawatt hours or more. And that is, if you look at the traffic light model, that is in the green phase. That is in the unconstrained phase where any quantity of power can be delivered without restrictions, without any congestions. There are other layers in the hierarchy of the grid, and also in the, if you like, in the hierarchy of trading. There's a middle layer where we talk about flexibility. Flexibility is more regional. Yeah? You use flexibility in order to mitigate a congestion situation, for example, in the medium grid layer. Or also in the smaller ones. But I would say flexibility is something which takes place between a couple of kilowatt hours and a couple of megawatt hours, or let's say capacity-wise some kilowatt up to some megawatt, which is contributed by consumers, by industrial consumers, and the project that we are doing here is called New 4.0. And the participants here are, for example, ArcelorMittal and Trimed, who are capable to contribute flexibility of 10 or even 20 megawatt, just to reduce or just to mitigate congestion situations in the grid. And this, of course, also stretches into the yellow phase, where congestions appear, but where the way to cope with them is still market-based. Yeah? And what we develop here is a market-based decentralized infrastructure which allows to offer flexibility in an order and execution way, as it is also the case with Enerchain. And then, of course, we have at the lower level peer-to-peer trading in the microgrid. This is neighbors. This is kilowatt as far as capacity is concerned. And this is prosumers on the one side with their solar panels, and consumers on the other side, just receiving, having automated devices which do the trading. Yeah? What we are going to develop in the ET block project is a so-called blockchain device, which does the trading automatically. But as this focus on the head quarter hour, we talk about a kilowatt or a fraction of a kilowatt, yeah, and there are a lot of challenges around that. Is this a viable business process? Is this compliant with GDPR regulation? Is this technically possible? Yeah, can we allow for enough throughput for that? So these are challenges at this lowest level of energy trading in the local grid. So let me now proceed with the Enerchain project. And Enerchain, as I said, is about wholesale trading, and Enerchain started about 2.5 years ago. And the actual trigger, or the big bang, which initiated the Enerchain project, or which let us think about decentralized trading, that big bang was the broken microgrid. Yeah? Maybe you remember that if you're a little bit blockchain affine or blockchain and energy. That happened in March 2016 when the first kilowatt hour was sold in a decentralized way over the Ethereum blockchain from a solar panel owner to his neighbor. And so we said at Pontong, well, we are the two in B2B, yeah, that is our slogan, and our tradition is to support energy traders in post-deal processes, so we have a focus on wholesale energy trading, and then we thought to ourselves, how can we support this? Because this is actually our core business, B2B integration. So it's all started with a book chapter on decentralized trading, written back in May 2016. Then we developed a prototype. That prototype was presented on this conference, on the EMART actually, 2 years ago in Amsterdam, where we presented in public the first energy trade over the blockchain, but that blockchain still ran on my laptop. Yeah, so it was 2 nodes on my laptop. Then we started the actual EnerChain project with a workshop early last year with a growing consortium. We had up to 45 participants in this consortium, and we redeveloped everything again. A year later, so a year ago from today's point of view, as Marius already said, we had this legendary first live trade over the blockchain, but this time the blockchain was deployed in the cloud across several clouds. Yeah, it was the Amazon AWS cloud plus the Microsoft Azure cloud, and it was the traders and their organizations directly connected to the nodes of the blockchain. And it was, for example, E.ON and Enel who did the one trade, and Wien Energie and Aeneas doing another trade in a decentralized way. So that is how it all started. Where are we now? We are now in Q4, as we know, 2018. And the status is that after we have initiated this project from a Pontong side, the question is, does it make sense to have one operator, being a third party, being us, operating a blockchain, which is then used by a consortium? Is that decentralized? Is that as decentralized as possible? Probably not. Yeah? So the end state, if you like, would be the consortium running the nodes, the consortium owning the nodes, and also the consortium owning the software. And in order to get into that situation, into that status, a lot of more than just developing the software is needed. There is a lot of activity required as far as the governance is concerned. Yeah? How are the rules for those who participate? How do they integrate? How do they close a contract, and with whom? Yeah? Is it a peer-to-peer contract, everyone with everyone, or does it make sense to have a central organization just as a central counterparty for a membership contract, for example? How is it with the decision-making process? How is it with the funding process? How is it with the strategy-making process? Yeah? What comes next? How to structure all this? And this is what we are right in now. Yeah? So this is what takes time, because this is also a decentralized process, but it will lead to founding a legal entity which represents EnerChain. But this doesn't operate the system. The system is still an infrastructure which is decentralized. It's operated by the participants, and having a legal entity, having this foundation as a legal entity, is just to ease the process, the governance process, and the process of cooperation. So that is the next steps, and I think we will also hear from our colleagues who will speak after my presentation a bit more about this. EnerChain as such has more than 40 participants who participated. We received very nice, how is it called, comments as being one of the most innovative projects in the whole energy space, so I'm quite proud about that. Maybe a little bit on how it works. This is a trading screen of a market participant, of a trader actually. These are the nodes of the blockchain, and we have further market participants. And what they do is they exchange data. Yeah? The only thing is they don't exchange data through one portal or one hub or one platform in the middle. They just use the blockchain as a mechanism to transfer the transactions that they exchange. And if the guy over here enters an order into his order book or into his trading screen, the order goes through the grid of the nodes. This is like Bitcoin, where you submit a payment transaction actually, and it's processed by the nodes using a validation process. So this is blockchain again, which avoids that we have a double spending situation, that the status of the system is kept consistent, and of course it's stored in the blockchain, which means it's highly available. So if one or two nodes crash of the system, people just don't need to care, yeah, because it's resilient. The nodes may start up later and may reload the history of what has been transferred over the blockchain. And so, like other blockchains, this is highly available for the participants, but at the same time, the operation cost of such a node is quite low. So the order is then processed. It is part of a new block. By the way, this is very fast for blockchain terms. It is a block is created every second. So after a second latest, the order is received by the participants, pops up in their local order book, and they can click then on the order and execute that, such that it is consumed, yeah, by an aggressor. So the first one is the initiator, the second is the aggressor. That's the old OTC broker model which is applied here. Let me go ahead. I think this is my last slide. Just a little bit about how the software architecture looks like. Okay, because we tried to find a blockchain technology which satisfies our requirements, and we couldn't find one. The only thing that we could find which was useful was the Tendermint consensus mechanism, or Tendermint blockchain if you like, which is quite fast, but it lacked certain functions that we need for a consortia blockchain, like Enerchain. Yeah? Like, for example, authenticating the participants, exchanging certificates, reconnecting. If a node fails, then of course your system should automatically reconnect to a different block. This is all technical stuff I don't want to expand on. So as a result, what we developed, apart from the existing Tendermint nodes down here, was a middleware on top of that, which helps to implement distributed processes to coordinate applications on top of that. And since distributed processes are not just trading, it's everything. Yeah, it's everything which might be blockchain-like or blockchain-affine, where we publish transactions into this sphere such that others can read that. So we want to specialize that. We want to verticalize this infrastructure. And in the case of Enerchain, there are plugins and applications on top of that. So for example, the trading tools on top of that, and plugins which implement specific logic, which is Enerchain specific, which can then be put into these components of the architecture. If there's a different process, and we do different processes like grid chain, for example, in the grid management and balancing power process, then of course this logic is completely different, but it can also be plugged into this basic infrastructure. So that is the wormhole blockchain middleware, and as we are doing about 5 blockchain projects altogether, the wormhole framework is the essence out of the different projects in order to support them in the same way. Yeah? So we started with a new 4.0 project at the end of 2016. We started developing the wormhole framework, then Enerchain kicked in. So some Enerchain requirements also influenced the way how we built the wormhole project. Then other projects kicked in, and we have the feeling now that we are quite mature with the wormhole blockchain, with the wormhole framework, because we did a lot of tests. We did load tests. We did tests with mass participants. We did tests with nodes scattered across various cloud environments, and we have the feeling that we are now, so far, that this is a product of its own kind. So that's what we are also quite proud of at Pontong. And that's it actually from my side. We will have a Q&A session after the next 3 presentations of my colleagues. So if you have any questions, I ask you to wait maybe another 20-30 minutes, and then we are available for your questions. If you would like to visit us, it's just over there, our stand, the Ponton stand, so just 50 meters away from here. If it's not today, of course, we are still present tomorrow if you have any further questions. So I would like to pass over now to Roland Beck from OMV, who will talk about the status of Enerchain and probably also the governance plans. And after that, Gonzalo Rio from EDP, who is a technical head within the Enerchain consortium, and then we have Timo Engelke as the third one, who is the product owner for the software development, and who is, so to say, also the interfacing person between the Ponton side and the consortium side. All right.
Thank you very much. When you listen very carefully what Michael mentioned, and at some point in time during his presentation, he brought up a lot of questions, how to set it up, how to actually govern such an entity, and we didn't have any answers to that yet. And the matter of fact is that it's under development in terms of the consortium that's been set up and the companies that have been mentioned, and looking at the development and evolution of the Enerchain project itself is also evolution towards how do we operate that in a production environment. What I would like to address briefly to you is how is the consortium set up, how do we operate, what is our objective, and what are our achievements and our further goals. To be very candid, this is the slide I have prepared, or not prepared, so there's it's a very blank slide for you guys, so you can fully focus on what I'm saying to you. I would like to start out with just connecting to what Michael mentioned earlier. In the evolution of the Enerchain, it started out with a prototype being prepared and developed by Enerchain by identifying a business need and an opportunity to use blockchain as a technology for a stronger connection between energy traders, and use that platform also in a way to reduce eventually transaction costs and eventually also open up the new technology for further developments. The current use case that we're looking at that's been developed is specifically focused and geared towards the trade execution part. So we're looking at how can the technology that has been developed be used for reducing the transaction costs at the point in time that we close the trade. There are options to look into further developments further out on how we can utilize the same technology and the same infrastructure also for downstream processes in terms of post-trade execution. Right now we're focusing solely, and this is the first use case and also the most prominent one, also with the use cases and the examples that Michael shared on previous conferences where trades were already closed, to make this accessible for all wholesale trading participants. On the one hand, when we look at what the consortium does and how it's set up, we have multiple companies, and during the evolution we mentioned, or Michael has mentioned earlier, that we had during the POC phase when all started and the development was geared up to 45 companies, different energy trading companies contributing, sitting in with Ponton to validate their assumptions, to review what has been developed, run test cycles, provide feedback on that, also develop new ideas on how things need to be developed in order to accommodate proper trade execution. In the current phase that we're in, and it was mentioned earlier with the questions that were raised, we're now looking into what can we do in order to use that developments that have been done so far, and how that can be put into a product that can be marketed on the market itself. The consortium that's currently consistent of roughly 26 entities that are more or less the core team that is contributing and working towards that goal are the companies that are looking into how do we as industry not as a software provider, not as a third-party company, but as an industry backup such a development that we can establish ideally, and that's the current goal, that we establish a non-for-profit entity that runs the necessary facilities to allow trading entities to enter and use and utilize this infrastructure. And how can we utilize also the industry as a mechanism and the industry participants to establish such an entity? The current focus that we have is finalizing the developments that are needed in order to have a minimal viable product, in order to actually get it out to not only the 26 current participating companies, but every other energy trader who's interested into that. And on the other hand, allowing also a governance structure of the operations to reduce, on the one hand, costs and reduce the effort to actually onboard new companies. We currently have a structure of the consortium where we have 2 chairpersons that more or less moderate and run the consortium with 7 different working groups, which all of these working groups are populated by the participating companies. All of them are professionals that do that next to their day-to-day job with the experience out of trading entities. So there's a lot of experience within the working groups and in exchange of these working groups in finding the right pattern and the right way to actually set up a proper operation for running the enerchain in a live environment. The participation of any energy trader or energy trading company in this consortium is open. There's no restriction in terms of who's admitted to it. As a matter of fact, we're welcoming anybody who wants to join. And we certainly look into the distributed fashion of the technology also in a way that we want to establish our the entity in a way that it's supporting such a mindset. So when we look into the structure of the consortium with those 7 working groups, the working groups are geared towards preparing for decisions, but the decisions will be taken by the plenary of all participating companies. And that allows us to gain transparency and also make sure that the know-how and the experience of all energy traders can be utilized in order to get the best solutions out of what's currently possible. We are, as mentioned earlier, currently in the phase to finalize the MVP, meaning that the product that has been developed over the POC phase and the further development, that this is finalized and utilized or possible to be utilized in a production environment. And in parallel, we're setting up the preconditions to have an legal entity that holds the IP rights. It is not intended that this entity will actually run the infrastructure. So the idea is that the infrastructure will be run by the participants themselves. And the idea is that the entity itself is more or less a governing body rather than a service provider of the infrastructure itself. And with that in mind, we are currently looking into a time frame of my latest information is looking into the next half year of developments, and that's my current expectation that we'll be able to finalize the last bits and pieces to establish the necessary structures commercially, legally, and also technically in order to go the next step. And I'd be more than happy to take any questions after the next presentations, but also in any way after this conference. We're open for any comments and any other energy traders who are looking into how that use case can be a benefit for their companies and how they can contribute. So much of what we've seen already now, what has been shared technically, is a product of joint development and joint search for solutions. And what we saw so far is that there is great potential in using this technology for reducing costs on a transactional basis, and also enabling us to further develop into new use cases. So I'm glad that I'm part of this initiative, and helpful for me also to look into new perspectives and also gain experience from exchange from other energy traders who contribute on the same level as the other participants. So from my side, I'd like to hand over now to Gonzalo to look into the more technical side, and I'm happy I'll stay here for further questions or comments as needed.
Thank you. Well, regarding the technical work group, the first thing that I must say is that these work groups work together and very closely to Ponton. We don't make decisions individually, but it's our purpose that we find the most technical viable solution in order to get the decentralized solution, as Michael have mentioned previously. This work group, just for your knowledge, has already 10 people from all the companies present on the consortium, and I have just put several highlights to point out that we are completely active, and everyone is contributing in a very positive way. So up to this moment, we already did 2 end-to-end tests to test technical environment. Of course, we detect improvements. That's part of the business. The one very important thing to mention is the fact that the tests were made with the several participants hosting parts of the architecture. I'm not going deeper in this level, but I'm able to answer your questions if you have some curiosity about which part of the architecture were hosted by each one of the participants. The tests have shown 3 things, basically, that these components can be run on premises of each one of the companies if they decide it, but they also can be hosted on the cloud services, as Michael also mentioned, in AWS and Azure. This is already tested, and it has gone with success. Another point that was mandatory for us, and that we reached this goal after the last test that we made, is that the transaction of the blockchain would have to take less than 1 second, and we reached that milestone on the second end-to-end testing. That was briefly the message that I had to send to you, but of course I will be here to your questions. So I will pass now to Timo, which is the product owner. He will speak a little bit about the product itself and the methodology. Thank you.
Okay, yeah, my name is Timo Engelke. I work for BKW, it's a Swiss-based utility company, and my role is the product owner of the product. And the product owner role is something that derives from the agile development principles that we are following in this project. And I will take a couple of minutes to explain what that actually is, the agile development, and how we do it in the Enderchain project. So first question, why would we use an agile approach? And I'll come to what it is, but first, why do we use it? And this is actually a common problem in software development that is known for a long time. And this was actually the first slide that I was presented when I started studying, and it's still very valid. It's from 1973, you see. And this is the way usually a product was developed, and with all the problems that came. So in this case, there's a swing to be developed, and in a first sketch it was something with 3 boards, and then it went to the next step where the designers came into place, and they already did something a little bit different. They implemented 3 ropes instead of 3 boards. in the next step, the systems designer designed something that was even different from the previous step. The programmers, they coded something that was different again. And then at the customer side, they had to install something that was working, so they came up with this solution. And the end of the story is, this is actually what the customer wanted. So all these efforts have been spent, and in the end, they figured out the customer wanted something completely different. So, and to overcome these problems, the agile principles were developed. And what is it? So generally speaking, it is a mindset. And in another way, it is a way to manage the software development project. Meanwhile, this has become so popular that this came from the Silicon Valley and it was dedicated to software, but it's used in many different project types by now. So this is how we used to develop products. Like we had the requirement to develop a car, and so they started with developing the wheel, making the perfect wheel, then connecting it together so it'll be two wheels. Then maybe they added the engine, and in the end, the chassis. And only at the very end, the customer was happy that, yeah, this is the product that I wanted. This is not how we're going to do it. That's not agile. Agile is an approach that looks like this. What you do is you take your requirements down to the very essence of what you want. Like, in this case, you want to transport persons or goods from A to B. So let's start with something very, very basic that is very cheap, just to see if this is actually the right thing to do. So you started with the skateboard, then you do an iteration and you end up with a scooter, with a bike, with a motorbike, and at the end you come to the car. And you see the customer is only starting to be happy with the bike, but before that he can agree on, yeah, this is something I wanted, but I want improvements, right? So if you do a failure, you want to fail early. And if we take this in relation to the Enerchain project, and maybe the skateboard was like the first trade that Michael did on its laptop to demonstrate it. It was limited, it was all local, so it did not fulfill all the requirements. What we want to do now is developing the minimum viable product, the MVP, and that is basically the smallest piece that you can develop that delivers a business need that all parties can agree on. And that's maybe the bicycle. So we're not heading for the Ferrari yet, we're heading for the bicycle. Right? So in this first step for the MVP, and then do incremental iterative implementation on top of that. But first we want to get something that is working, that delivers a business value. That's the main definition of the minimum valuable product, or walking skeleton as it is called. So what's my role as a product owner in this development for Enerchain? Basically, I need to break down the high-level requirements into actionable user stories that the developers can actually work with. So I need to take the business requirements and make them small enough so it can be portions that the developers can implement. And I'm doing that representing the whole consortium. I will come later to that. I evaluate the features versus the effort that needs to be taken to implement these, and make sure that actually the development delivers a business value, and that's the strong requirement. It needs to deliver a business value. Defining the minimum valuable product, like what is really the smallest thing that everybody can agree on. And then, of course, I'm like the interface representing the consortium of the 40 companies that are behind me in front of Ponton and the development team, and also vice versa. And then at the end, there's also acceptance or rejection of the increments that have been developed. So Scrum is actually a way of how you implement this in an actual doing perspective. And how we do it in Enerchain is we have two major parties here. First is the consortium, the 40 companies, or let's say maybe 26 or so are actively involved in the development. And on the other hand side, we have the development team of Ponton. And I'm like the product owner, the interface in between these. So what do? We create the requirements in the consortium and we discuss them so the requirements are clear with everybody, like everybody needs to agree on these requirements. And then we create a product backlog that contains these user stories that are the small pieces that the developers can implement. And I'll come later to what the user stories actually are. And we prioritize these, saying, okay, this is something very important, so we put it higher up, or this is something of lesser importance, so we put it down. We give this to the development team of Ponton then, and they do the sprint planning. The sprint is basically a time frame in which they develop a certain feature. They have a sprint backlog, and they then come back to us and ask questions if they understood something right or wrong, and there's a couple of discussions going on before they actually start developing. So it's, for the developers, it's absolutely key what they need to deliver. Then they do the sprint, and that's usually a time frame of 2 to maybe 4 weeks to implement these features. They do a daily meeting every day. They meet and talk to each other about what progress they achieved, what is still missing, if there's uncertainty or they're not so clear about certain things. That happens on a daily basis. And in the end, there is a final work piece that delivers a additional business value to the product. That's the definition of the finalized work. And then there's an acceptance test that we defined up front where we, as a consortium, test these features if they are really there. And then in the end, we have a retrospective where we all sit together and evaluate what went good and what went wrong. So for the next sprint, we can have an improvement. That is basically the Scrum development process that we are following. And what's the user story? So the user story is the piece that the developers can implement. And I have one here picked out of the Enerchain project. And that is, as a trader, I want to be able to use a panic button in the GUI to be able to cancel all my orders. So this is a requirement, and there's a little bit of explanation so developers can understand why we would need that. So in cases of emergency, at sudden market movements, I want to be able to cancel all my orders. Or as a trader, if I want to leave, if my shift ends, I want to be sure that none of my trades is still in the system. So that's the requirement. I want to be able to cancel all my orders. And this is the work piece that the developers can then implement. So it ends up with a button in the GUI that actually says, cancel all orders. Yeah, the agile development comes with a couple of challenges in this project. And one of the challenges is that I'm one person, but I'm representing 26 or 40 other companies. And we need to agree on things. If there's discussion going on, then I have to go back to the consortium and get a consensus from them. And this is a slow process. This takes time. And we don't have a face-to-face development. We're spread all over Europe. We're meeting regularly, but usually in an agile project approach, you want to have face-to-face interaction. That's one of the requirements. So this is something we're missing. The big benefit of doing that is we now have a broad support from many relevant market players to ensure we deliver a valuable, relevant product. Like we need to make sure the product that we are developing is relevant to the marketplace. And we have 40 that go into the discussions, but in the end, it should be valuable for all of these. So in the end, the product will be valuable for all these parties, hopefully in the end. Yeah, that was actually my part from the development side. And I think we can start with questions now.
So are there any questions regarding any of our presentations? And do we have possibly a microphone for the audience if we... there's a magic cube. There's a question, or there.
Would you allow outside European company to participate in this development process?
In general, yes.
Okay.
Yeah. We have so far we have not had.
We are
any.
from India, one of the largest electricity trading company. So can we be the part of this process?
Yeah, if you want to trade and find a counterparty trading here in Europe,
right.
Of course, looking into a peer-to-peer trading infrastructure. No matter where you sit around the globe,
okay.
You need to find products that you'll find a counterparty to trade with, right? So, right now, the companies that are participating, I doubt anybody of them would currently trade Indian power. But if you would be willing to trade European power at one of the trading hubs?
No, not in European. Can we be part of this development process to just learn more, maybe more future products? Because we have a large grid. We are already sitting on 350 gigawatt grid. Maybe we have another 10 years, 900 gigawatt grid.
Yeah. So in general, yes. I think, as I mentioned, it's open for everybody. Okay. It's not an easy say yes or no, but please, come and talk to us and find a way to collaborate.
I think you should have a discussion after our session here, yeah. And there's a full day tomorrow also to discuss this. Yeah. I think there was another question over there. If we, yeah.
Okay, thank you very much. My question would be, you've mentioned that you are formatting a legal entity around the EnerChain. Now, would this imply that under current legislation, EnerChain would constitute as an organized marketplace? No.
No, the answer is no, because there is no system that is operated by a single party. Yeah? It's the market participants exchanging messages with each other. But it's not a platform, it's not an operational organization in that sense.
Thank you.
Any other question? No? Okay. So again, if you have where? Yeah. All right.
Thanks.
Okay, two more, yeah?
Thanks. Is it designed for physically settled trade as well?
Yes.
Yeah?
Yes. It's only used for physically settled trade and not for financial trades.
Okay. All right.
Yeah. There was another question over there.
Thank you. How is the regulatory reporting part going to be done for the trades concluded on EnerChain?
At the moment, it is like a bilateral trade. Yeah. So if two traders don't use an exchange or a broker as a platform, but have a bilateral trade, they are of course also obliged to report this trade. And the status quo is that they would just report the trade in exactly this way. What could be done in the future is that there is an adapter which is connected to the blockchain, and whenever a trade is concluded, that this is reported to the regulator through the usual platforms. Yeah? There is an RM required in order to concentrate the trading reporting flow vis-a-vis Acer, for example, and that would have to be done as well. Yep. Okay, so if there's no further question, no problem. If any question comes into your mind, we are, as I said, already just over there, 50 meters away. And we will be present the full day tomorrow, so feel free to approach us. All right, thank you.
Okay, thanks a lot to the EnerChain team and for the interesting presentations. And now it's only my task to wrap up. I think what we saw is that that there are several digital solutions to improve trading, to reduce costs of trading, energy trading, and even blockchain projects, and this is a perfect example for it, are not just projects out in the sky for the next 15 years, but they are happening today, and I think the EnerChain project is one of the perfect examples to show how fast such developments can go, even though EnerChain as well has a long road ahead of it. But it gives the right spirit, and I'm really looking forward to the presentations next year here at the European Utility Week, then in Paris, I think. And so I thank you all for the questions, and I thank the different speakers for their presentations. And I wish you all now much fun on the Traders Party and another productive day tomorrow here at the European Utility Week. Thanks a lot. Bye.